It would be talk about index optimization for any databases, but mostly about MySQL. I want to ask you how using MySQL. Okay, who using Postgres? Okay. If you want to follow this talk, you can open this link and you will see everything that I will show you. It would be easy for them who are sitting the back line. Okay, who I am? My name is Pavel Scherbinin, nicknamed Zirtik. Now I'm a leader of Moscow PM, main organizer of YAPC Russia. More than 8 years programmer of Perl, team lead, DBA, and lecturer. And it's a reason because I will tell you about indexes. We have a very interesting project that names Technopack and some of the same projects. And we lecture at the universities in Moscow. And we have a lot of students who have our lessons, and we, during 2 years, help them to be system architecture. And one of the courses at this period is a course about databases. It's my course. And at this course, I tell students a lot of things about databases, how to optimize indexes, how to write queries, and a lot of things. We have 2 years degree and more than 40 courses, more than 60 students every half of year, and some additional courses, and one of them courses about Perl. At 4 universities, we now have additional course for Perl, and it's more than 30 students on each. I think it's great. Okay, I will tell you about indexes, how it works, and how to do it better and faster. I think to imagine indexes, this example would be phone book. If you want to find some phone, you open your phone book and check first letter and looking the needed page. And on that page, you scan it and looking for people who want to call. It's like B3 works. Who knows what B3? Yeah, how it okay, let's see how it works. At the first leaf, we have all the first letters, and after that we go down and see in other letters till we found information that we stored on our disk or in other places. It's easy for one column index, but it's not very easy when we're using multiple column index. Let's imagine very easy table. People, we have after increment ID, last name, first name, date of birth, gender, and primary key by ID, and secondary key by last name, first name, and date of birthday. It's easy to have index by primary key, and we have sorted our IDs, and after that we can find the node where we collect our information. But if we are using secondary key, we have structure like this, and there are a lot of people who really don't understand how to look up for secondary index. Let's see this picture. Can we find somebody who has name Kim? How we can do it? Okay, we need full scan for it. We can find it in indexes, but we have this column in secondary index, but it's second column. We can find between using we can looking beside using first column at index, and of course we can find anybody with name Kim. To imagine how it works, you can try to connect every words in one long word, and it would be alien, Cuba, and date of birth, and it's like database looking for it. If you scan everything, you can scan just only for first letter. If you can find people who have the same last name, and you can find first name in the same last name, but you can't looking for the first name. And I will show it a little bit later. And there are two ways to imagine it. You can imagine it like a concatenation, three words, and you can imagine it like a tree. Oh, sorry. Yeah. It looks like a tree. We can go during the tree only by one way and only by one leaf, and you start from last name, and you can scan only by it, and after that looking for the second name, and only after it you can looking for date of birth. You can't looking for date of birth if you did not see if you did not know first name or last name. Okay, what we can do with indexes? Of course, we can do we can search by full equal. As this example, you can see that we can find an information that if we know forum ID and have an index by forum ID. If we're looking by equal of any value, it would be easy for looking at indexes. Another example by full equal, it's a multiple index for two columns by forum ID and also, and it's easy to find information at it. We could looking by left prefix, and for index forum ID also, it would be good work for looking by forum ID, but it would not be work for also. It would be full scan if we would be like to find also this index. Also, we could find by column prefix, and we could use like, but if we use person symbol at the end, we can't use it at the beginning. It would not be work. We could use, if we want search by range, it would be easy. If we have index forum ID and search bar forum ID more than 500, it would be work great. And maybe if we're looking for forum ID between 500 and 750. We can search by full equals plus by range. If we have forum ID and replies count index, we could know forum ID as equal, and range by replies count. But if you try to range by replies count and did not know our forum ID, it will be full scan. What we can do: search without left part of index. I did show you a lot of times, but the same example, forum ID, replies count also. We could not search by replies count, and we could not search by also. It still not works. We could not skip columns. If you would like to search by forum ID and also, we only will using part of forum ID. But there is one more problem, and if we would like after range seek, we need to scan every single information again. Forum ID more than 500, and we could not look up by replies count. But it's a little bit lie. Sorry, because since MySQL patch 6, MySQL 5.6, they create index condition pushdown. It's very interesting thing that I want to tell you right now. If we have this index, forum ID, replies count, and also, and we decided to scan forum ID by range, and after that wants to find something where replies count more than 1000, it would work fast enough, because till MySQL 5.6, for each rows where forum ID more than 500, database looking to a disk and starts to find any rows which have replies count more than 1000. But after MySQL 5.6, they could find it at the index. We have this information at index. Index already warm up and whole index in the memory, and it's easy to look up index and not go to disk and looking for information there. And it's works really fast, more than for some examples it could be faster more than 1000 times. Very popular things that you can find in a lot of topics which describes index condition pushdown. It's that you can using like with beginning percentage after lookup or after other things. It would be very fast, because all information for this world already we have an index, and we need just search by index. It's a very fast and very popular thing. Okay, when we use indexes, and the first thing where we're using it, we see it in a lot of examples previously. It's search by where, and I gave you some quizzes. I think you already ready for difficult queries and ready to create awesome indexes with me. And the first question would be count from topic, title like help, and replies count more than 100. Oh. Yeah. Which index will we use? Sorry? And? Yeah? Yeah? We know about index condition Pushdown, and it will be very useful to use index, replace count, and title in this order. You could not use title and replace count. It would be another index. It could not be work. Okay, another example. For my D replace count. Okay, for this. Yeah. Yeah. Yes. It could be both of them, form ID replace count and replace count of form ID. There is no difference. Okay, the second part where we can use indexes, it's join tables. If we want to use table join table 1 and table 2, and after that table 3 and table 4, database can make decision to don't do it like you want, and it can do it in another way, and connect table 1 and table 2, connect table 3 and table 4, and after that connect them both. And it's very interesting when database and how it can join the tables, but we will not talk about it, but you need this information for solve some problems, and look for some examples. Let's imagine this query. We have table 1 and table 2 connected by using column 3, and try to take table 1 column 1, table 2 column 2, and with where that table 1 column 1 in 5 and 6. And let's see how database sees this query. We have first iterator, and search over table 1 where column 1 in 5 and 6, and after that for each row in that iterator we have new iterator for table 2 where column 3 equiv outer row column 3, and it's an easy way to understand which indexes we need. For previous query, it's very difficult to understand which indexes we need till we understand how database it's. And on this example, it's easy because we know that for table 1 we need index by column 1, And for table 2, we need to index just for column 3. That's all. It's more interesting if we try to imagine how database see left join. At a left join, we added only one expression with if. If we have inner row, we do the same that we did at the previous slide, and if we have no, we add output null. And here we understood that how I tell you the previous slides, database can change order in join tables, but if you're using left join, database can change because it's very important in which order they are.
Is that something that you wrote, or is that something that you can generate?
It's a myroad. And we can imagine it. We're looking for table 1 for column 3. Column 1 where we have 5 and 6, and looking for table 2 with column 3 have 1, and we have 6 rows. Okay, it's a quiz time. We have forum join topics on FID equiv T FID, and where FID equiv 5 and topic replies count more than 500. We need to know indexes for both tables. Forums ID. Why? Which table we will use first? No. Yeah, we need to use first topics. We know enough information for looking at topics because we know that at topics FID equiv 5, database understood if you write f.id equiv 5, it's the same that topic feed equiv 5, and it understood that they need they can looking at table topics and search by feed and replies count, and after that for each row in topics it connect forum for it. Yeah. Yes, of course. Yeah. Yes.
That's what we imagine that we would do.
Yes, database is very interesting place and very complicated because for different problems for different data sets, it could works in another ways, and you need to understand how it works to work with it. And it's most popular example where we know that replies count is much enough. Okay, yeah. Yes, there are another decisions in this for any different data, and sometimes it could be very easy to looking by forums at first, and after that looking by topics. But this example, I think it's most interesting way. And of course, we're looking, we see and try to create indexes when we know only just one query for our database. In real projects, you have a lot of queries and you need to optimize them all, and you can choose another different ways. Okay, more difficult question. It's a left join, and we are looking for forum ID eq5. It's easy. Yes. And we need only index at topic. Oh, no, sorry. We need forums because it's left join. We need all information from topics, from forums. And for this query, we need index for forum ID and for topics FID. If we add information to left join, okay, we still need to scan forums first, because it's a left join and we can change order. And we start looking for forums, and after that connects topics for the same indexes. But in another way, if we change position of and add it to where, not to on, what it will be? It's a very interesting example because after we add T replies count more than 5,000, it's still not left join. It's already inner join. There is no way where T replies count could be null, and you have no any rows where it would be null, and it means that you can't have left join. It's already inner join, and database know it and already can change order. If you want to see it right, you can use explain extended, and after it use show warnings, and you will see the database rewrites this query to inner join. Okay, we could use indexes for sorting and grouping tables. For this example, we will need to use forum ID and create it at index. Sorry? Why? Okay, sorry. It would be the same for ask and desk, because how we know information at index already pre-sorted, and they connect the leaf nodes to right side and left side, and we could search by ask and by desk the same. The same for group by, there is no difference. We will group when we know information about our groups, and it will be very fast. It's easy works for max and min, because information, how I already told, at our index is pre-sorted, and if you know forum ID, it's easy to know the first item in it and last item in it. We know min and max, and it's easy. Very interesting information about covering index. What is it? It's when all information, it's your index enough for your query. You doesn't need any information from disk, from data. It's all in index. It's very compact. It's very fast because you don't using data sets on your disk. You're using only your memory. It's already pre-sorted, and it's cached better than information at your table, because a lot of databases cache indices better. Is the example of covering index. Which index we will use for cover it? Yeah. In right order, which columns in right order? Form ID, replies count, and also, yeah. Okay, the next theme would be about clustered index. It's a very interesting theme because for InnoDB it's default scheme, and you can power off it. And clustered index means that all information that you have at primary key is a clustered index, would be sorted on your disk in the same order as information at index. All information would be closer. It's easy to understand if you're using primary key with ID, and each page that we see on a picture would be very close together. But we have a problem with it, but I say you about it a little bit later. If we try to understand how it works at MySum without clustered index, we know rows and row numbers that we have on our disk, and our index have a link to row number. And when we try to find information at index, we're looking for our column, and after that we know in which row we have it. And it could be a lot of different rows. We will need to scan one page, after that another page, maybe a lot of pages. It's for first index, for primary key, it's for secondary index, the same, there is no any difference. For InnoDB, it's another way. All information that you need that you have already at the index, and index already sort information. And the secondary index looking for information, and he already have the primary key. Whole secondary and index have whole primary key in it. If you have primary key for maybe 3 columns, each secondary index will have 0 column and plus 3 columns of primary key. And the first picture shows us looking for first column primary key, and the second shows us how we're looking for secondary key. And how we can imagine it. For you, right side it's MySum, left side it's InnoDB, and why it's good and why it's bad. We have whole information very close to both to another information, the information that very interesting for us, and it's very easy to take it from disk. We if we want to scan something by index, we have already sorted information to our disk. When we add new information, we add it at the end of our page, and when page full, we create another page. But if we're using for clustered index primary keys that not going in right order, we will have a lot of problems. Let's imagine unique Y key like UID that could be very different and not be in right order. And you will see that every time you put information in strange places. And when you try to add some information in the middle of page, you need to break it and slice, add information, compact, and sometimes you will not have enough memory, enough place for new information, and you need to break your page to 2 pages, and it's a lot of places you need for store information in clustered index, and it's a problem. But there is a lot of good points, because you have very important information closer. Let's imagine examples that we see in a lot of our examples, and I want you to give example with replies. You have replies, and replies connected to one topic. How do you think? What's the best primary key for replies table, if you know about clustered index? The most often queries that we will use, it's take information by one topic. And it's very important to have information about a topic in one place. And it's very interesting if you will create primary key by topic ID and comment ID. All comments for one topic would be sorted on disk and would be sorted in your topic. And when we will try to take last 20 comments, you will take only 2-3 pages. If you did not use clustered index and use primary key by ID, you will look up by 20 pages. It's faster more than 5 or 6 times. It's really very fast. It's very important thing. Okay, it's a quiz time again. It's a very difficult quiz. Would be ready. I like this quiz to answer at job interviews because it's very interesting and show how people understand databases. Okay, we have it's a real quiz from my life, and we're using this for our database, and we have 2 tables. One, it's about news. It's all news on our side. The second, it's a story. It's a place where we connect news about one topic. News, we have a lot of news in one story, and one news could be in a different stories. Which connecting them? Okay, it's many to many. And how we realize many to many? Yeah. We have another table. Let it be SN, where we have news ID and store ID, and connect the both tables. And very easy query. We need all news from one story sorted by time. It's very easy query. Select from story, inner join, ascend, story ID, inner join use, where story ID some information, and order by news time. Okay, which index will we use? Yes, for ascend it would be story ID and news ID. For news, no. Okay, for the first, we does not need story. We could use only information from news and ascend. And if we will try to compose it, we will see that we looking for ascend where story ID have some ID, and for each row we're looking for news ID news, and after that we sort whole information by time. We does not need time at index and news because we can see it. Time would be ordered only in one ID. We doesn't need it at all, and it's a problem. We have a lot of news, and after that we need to sort it. It's very long. We want to do it faster. Yeah. 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 But it's too slow. Very slow. Okay, I will show you the magic. We can add news time to connected table, and after that we can rewrite our query to select from ascend by time. But we have another problem. Which one? We have a problem with consistency. It's news time. Yeah, it's a problem with consistency. And how we solve it? Foreign key. Foreign key on news ID time. And each time when it will be updated or deleted, it will be changed in our connected table. And it's working very fast. Okay, that's all. Maybe questions? Okay, so if you have no, thank you very much.